This is the second of two videos from Chapter 4, Section 3, and today we are going to be talking about isotopes and what that means in terms of mass number. Isotopes are, we're finding the definition, atoms of the same element but they have a different number of neutrons. So what does that really mean? If they are atoms of the same element, that means they will have the same atomic number, because that's really what defines an atom. An atom has a certain identity because of the number of protons it has. If it has a different number of neutrons, you'll be able to tell because it will have a different mass number. Remember, the mass number is the number of protons and neutrons added together. We can see here in these diagrams up above, we have three isotopes of neon. They're called neon 20, neon 21, and neon 22. When you see the name of the element written out like this, followed by a dash, followed by a number, the number tells you that's the mass number. And if you were to write this in symbol notation, neon would be, of course, Ne, and it would have a 20 in the upper left corner. Now, neon is identified on the periodic table as having an atomic number of 10, so we would write the symbol for neon like so. You can see that in the diagram up above, it has 10 protons, which are indicated by little blue spheres, and it has 10 neutrons, which are indicated by the green spheres. Okay, so added together, that gives you the mass number of 20. It's written here that it has 10 electrons. That's just telling you that 10 electrons and 10 protons, this is a neutral atom. So an isotope, you can't really tell that this atom has an isotope until we look at the second diagram. The second diagram is labeled as neon 21. Mass number is 21, and you can see that here in this diagram. 10 protons plus 11 neutrons gives you a mass number of 21, so we would write neon in this symbol. 21 up top still has 10 protons, that's what makes it neon, so 21 over 10 is the symbol notation. A third isotope, neon-22, because 10 protons and 12 neutrons add up to 22. So the symbol notation looks like this. All three of those symbols all have 10 protons. That's what makes them neon. But different number of neutrons and ultimately a different mass number indicates that you have three atoms of the same element with different masses. Those are isotopes. Example here, three isotopes of oxygen are oxygen 16, oxygen 17, and oxygen 18. Write the symbol for each, including the atomic number and the mass number. All right, let me scroll up so we can see this a little better. So to write that, the first one, oxygen 16, the 16 is the mass number, it goes up top. Looking at a periodic table, when you find oxygen, you'll find that the whole number in there is 8. That's the atomic number. Okay, that tells you that this isotope has 8 protons and 8 neutrons. The second isotope is oxygen 17. The 17 is written up top. It's still oxygen, so it'll have 8 protons. We put that number in the lower left. We still have 8 protons, but now we have 9 neutrons. The third isotope is oxygen 18. The atomic number is still 8. It is still oxygen. So we still have 8 protons, but now we have 10 neutrons. Those are three isotopes of oxygen. Three isotopes of chromium are chromium 50, chromium 52, and chromium 53. How many neutrons are in each isotope, given that chromium has an atomic number of 24? So if we were to write this out in symbol notation, chromium 50.
Casey, Ryan, please report to the technology office. Thank you.
All right. See you, Casey. Go to the technology office. 50 is the mass number. 24 is the atomic number. Subtracting, in this particular isotope, there are 26 neutrons. The second isotope of chromium is chromium 52. Subtracting the 24 protons, this particular isotope has 28 neutrons. And the third isotope, chromium 53, when we subtract those two numbers, we get 29 neutrons. So all chromium, all because they have the same atomic number, but they have different numbers of neutrons.